Hello, everybody, and welcome to topic number 18 adding and subtracting rational expressions. The objectives for today are to add and subtract rational expressions that have a common denominator already, identify the least common denominator, or LCD, of two or more rational expressions, and then learn how to add and subtract rational expressions with unlike denominators. We add and subtract rational expressions the exact same way we add or subtract fractions. So we remember that when we add or subtract fractions, we need the denominators to be the same in order to do it. So if I have p over q plus r over q, the q denominator would stay the same and we would just add p and r. The same thing is true with subtraction. As long as the denominator is the same, all we do is manipulate the numerator. This will hold true with rationals. We're just going to use our polynomial rules when we add or subtract. Let's take a look at the first example. So we notice the common denominators are the same, so they'll stay as 4. So in this one, we're going to do 1x plus 5x. That gives me 6x. Now 6 over 4 can reduce, so we'll take the fraction and reduce 6 over 4, and it will become 3 over 2, with the x coming along. This would be my final answer. For problem B, again we notice the common denominator is 7z squared. So all I'm doing is adding the numerators, 5 plus x. Because 5 and x are not like terms, we cannot combine these. We also see that nothing else is in common here and can cancel. So that would be my final answer for this one. C is a great example of making sure when we combine, we go through and see if we can simplify any further. We notice that both have the denominator of x plus 7. So here, I would do x squared minus 49. But x squared minus 49 should stick out. It's two terms. It's got a minus sign. It's got an even exponent and a perfect square. This we should be able to factor using difference of squares. The square root of x squared is x, and the square root of 49 is 7. That means the top here becomes x plus 7, x minus 7, with our x plus 7 still on the bottom. This is important now, because now we have things that are on the top and the bottom that will cancel. So these will cancel and simplify, and the only thing we'll have left is the x minus 7, which is our final answer. So even when we go through and add or subtract, we have to make sure and see if we can simplify at the end to get our final answer. For letter D, again, we have common denominator of 3y squared. So I'm going to do x minus the entire quantity of x plus 1. So notice I'm going to write this as x minus the entire second fraction. So I will put this all in parentheses because I want to minus both parts from it. I'll distribute the negative because, again, we're going to minus both parts. The opposite of x is negative x. The opposite of 1 is negative 1. Still over 3y squared. The x minus x cancel and simply leaves me with negative 1 over 3y squared. Make sure when we subtract, we want to subtract the entire quantity that is in that second polynomial. What happens if the denominators aren't the same? Well, then we'll need to find the least common denominator, the LCD of the polynomial. So again, remember, we used to have fractions like 4 over 6 and 3 over 4. And we would ask you to find the least common denominator that both of these had in common. Between 6 and 4, the smallest number that could both go into is 12. And then we would adjust the top by manipulating it. 6 times 2 is 12, and 4 times 2 would give me 8. 4 times 3 is 12, so 3 times 3 is 9. Then we could add or subtract these fractions. We're going to do the exact same thing here again, except the only difference is we're working with polynomials. So if we work with polynomials, we'll work with our factoring skills to be able to help find the LCD. Here are some examples. Here on letter A, both of the denominators are monomials. When we work with monomials, we're looking basically for the ones that have the most when it comes to the variables and then we're looking for the numbers that both 3 and 5 can go into. So LCD-wise, 3 and 5. What is a number that both 3 and 5 can go into? We know that 10, 5 goes into 10, but 3 does not go into 10, so that doesn't work. And we know, for example, 6, 3 goes into 6, but 5 doesn't go into 6. The smallest number that both 3 and 5 goes into is 15, so we'll use that as our number for our LCD. For the variables, we're going to take the highest variable exponent. So here I've got x5 and x to the first power. We want to take the biggest one, so x to the fifth needs to be in my LCD. Same thing with the y's. I have a y squared and a y cubed. We're going to take the biggest one as part of our least common denominator. So my least common denominator for this fraction would be 15x to the fifth y cubed. For b, we notice they're both binomials. So we're going to have binomials as part of our LCD. One of the things we notice is these are not the same. This is z plus 1 and this is z minus 1. So both of these need to be in my LCD. So my LCD would include both z plus 1 and z minus 1. For letter C, we can't find the LCDs until these are factored completely. Again, we're only looking at the denominators. That's what we're concerned about. M squared minus 25 is a difference of squares. It will become m plus 5 and m minus 5. The 2m squared minus 9m minus 5, we can use AC method to solve that. Factoring that, it gives me an m minus 5 and a 2m plus 1. This is a equals 1. We need to find a number that multiplies to 25 but also adds up to negative 10. In this case, it would both be negative 5s. So this would factor to m minus 5 and m minus 5. Now we're ready to make our LCD. We want one of everything that's unique. And then if it exists more than once, we'll put that as part of our LCD. So when I look here at the first fraction, m plus 5 and m minus 5 are each unique. They need to go in my LCD. When I look at the second fraction, I already have an m minus 5 written here, so I don't need to write it again. Here I have a 2m plus 1, which is not in any of the LCDs that I've done before. So this needs to be written here. Now when I get to the third fraction, I notice that both are m minus 5s. Well, in my LCD, I only have one written here, but this one has 2 within it. I need to signify that I need 2 m minus 5s to do it. So there's a couple ways that you could do it. We can write another m minus 5, and this can be the LCD. Or, instead, we can say it's m minus 5 squared, because we're writing it twice, and call that the LCD. Either one of these is acceptable. For the most part, they're going to want you to do it with the exponent squared as we can. For letter D, again, we're going to factor the bottoms and then look to see what they have unique. X squared minus 4 can be factored with the difference of squared. It becomes x plus 2 and x minus 2. Here we have a GCF of 3, and when I take that out, I get 2 minus x. Now for my LCD, I need everything that's unique. So I have an x plus 2 and an x minus 2. I have a 3, which I don't have in this fraction, so I'll include that in my LCD. And remember, these are not the same. These are actually opposites. So we don't have this here already. We need to include this in our LCD. My LCD should include one of every sort of polynomial that doesn't already exist. We need the skill to be able to add and subtract fractions, which we will do next. So to add and subtract rational expressions with unlike denominators, we're first going to find the LCD. We're then going to write each rational expression as an equivalent rational expression whose denominator is the LCD. So essentially, we're going to go through and find the least common denominator, and then we're going to go back and adjust the numerators for what parts of the LCD our original fractions didn't have, And then we'll add and subtract the numerator over that common denominator and simplify it as we can. So there's a lot of factoring techniques involved with this. We'll find our LCD and then we'll go back and adjust the top parts for what was missing. Let's show you some examples. So here we want to end up subtracting these. These are not common denominators. So we're going to need to make common denominators to do this. For my first fraction, I know I could do a difference of squares here because it's two terms with a minus sign, and both of these I could take the square root of. This would become k plus 2 and k minus 2. Minus, here we're going to look for a equals 1. We need to find something that multiplies to negative 2 but adds up to 1. Well, the only thing that multiplies to 2 is 1 and 2, and the only way we would get a positive 1 is if this was positive 2 and negative 1. So this would factor out to be k minus 1 and k plus 2. Now that the bottom is factored, let's get our LCD. We need one of everything that's in the denominators. We don't have anything that repeats in any of the denominators, so we're just looking for unique things. So I have here a k plus 2. I have a k minus 2. I have a k minus 1. And this k plus 2 we don't need to write again because we already wrote it here. Both denominators just happen to have k plus 2 in it. So there is my LCD. So now when I go to combine this, we're going to use this LCD as our bottom. So I'll write here k plus 2, k minus 2, and k minus 1. And we're basically done with the denominator until we get to the very end in case we need to simplify. Now let's go back to the numerator. Let's look at this first fraction. Out of the two parts here, the only part that's in the LCD that's not in this denominator is the k minus 1. So this is what I need to go back and multiply the numerator by. So I originally had 5k in the numerator here, and the only thing that was missing from this first fraction was the k minus 1. So I'm going to multiply this by k minus 1. When I go to look at the second fraction, it already had a negative 2. And I need to see what does this not have that the LCD does have. So when I go to look, I see it's got a k minus 1 and a k plus 2, but it doesn't have a k minus 2. That's what we're going to end up multiplying the negative 2 by. So we're going through and finding what it didn't have to adjust to the top. Now let's distribute. In this case, 5k times k is 5k squared. 5k times negative 1 is negative 5k. Negative 2 times k is negative 2k. And negative 2 times negative 2 is positive 4. We can combine these like terms here, and we would see that we have 5k squared minus 7k plus 4. Now again, we're not doing anything else to the bottom, so the bottom is coming along the entire time. The only time we would ever need to touch the bottom again is if we need to cancel something out. Well, in order to see if we need to cancel it out, we have to see if this factors. So we're going to check real quick if this factors. This would be AC method. I would need something that multiplies to 5 times negative 4, or positive 4. So I need something that multiplies to 20 and adds to negative 7. I've got 1 and 20, 2 and 10, 4 and 5. So when I look there, none of this adds to 7. So that tells me this can't factor any further. So this is as far as we can go on the top. And because we can't factor any further here, there's nothing that's going to be able to cancel out here. So this would be my final answer. So again, we're looking to factor the bottom to be able to find the common denominators and then go through and adjust the top as we need to. Let's do the same here for B. So again, we need to factor each of the denominators. Both of these can be factored with AC method. If you need to go back through your notes, go back through your notes to how to do the AC method. But for 2x squared minus 9x minus 5. This will factor out to be x minus 5 and 2x plus 1. We'll also factor the 6x squared minus x minus 2. In this case, this factors out to be 3x minus 2 and 2x plus 1. Now that the denominators are factored, we can find the LCD. We're going to take one of everything here that's unique. So I have an x minus 5. I have a 2x plus 1. I have a 3x minus 2. And I already have a 2x plus 1 here, so I do not need to write it again. The only time I would need to have a squared is if the same one existed more than once in the same denominator, which we don't have here. So this would be my LCD. This would be the bottom of my fraction. Now we're going to go back and adjust the top. We're going to look at each of the parts and see what were they missing. So here, this had an x minus 5 and a 2x plus 1. It did not have the 3x minus 2. So we would need to multiply this by 3x minus 2. This is a plus sign, so plus. Here we had an x plus 3. And we'll look here and we'll say what was not in this denominator that was in the LCD. Well, we have a 3x minus 2 and a 2x plus 1. It did not have the x minus 5. So we need to multiply this top by x minus 5. Now we'll go through and simplify. And again, as we simplify it, we're going to leave the denominator the same. We're essentially not going to touch it again. So for both of these, we're going to have to FOIL these. So we're going to go through and do our multiplications for each. And we could all just kind of multiply it at once and then combine like terms at the end. 2x times 3x is 6x squared. 2x times negative 2 is negative 4x. Negative 1 times 3x is negative 3x. Negative 1 times negative 2 is positive 2. Plus x times x, which is x squared. X times negative 5, which is negative 5x. 3 times x, which is 3x. And then 3 times negative 5, which is negative 15. We got a lot up there. We're going to look to combine like terms. Again, we're keeping the denominator the same. We don't need to touch the denominator until the very end if we need to touch it at all. Here I've got 6x squared plus 1x squared. That becomes 7x squared. For the variable with x, I've got negative 4x minus 3x minus 5x plus 3x. So negative 4 minus 3 is negative 7. Minus a 5 is negative 12. Plus 3, that will become a negative 9x. And then for my constants, I have 2 minus 15. 2 minus 15 gives me negative 13. We would look to see if the top can factor, which it will not in this case. So if it does not factor, we would leave this as our final answer. Let's go through a couple more. Here again, we've got these two fractions. We need to factor the denominators to be able to see if they can cancel. So 3x squared minus 5x minus 2. We'll look to see if we can factor that. And in this case, we can with the AC method. Again, if we factor it with the AC method, we should get x minus 2 and 3x plus 1 plus x minus 6 stays up here. Again, we would factor this with the AC method. Here I would get 3x plus 1 as well as 2x minus 5. For my LCD, I need one of everything that exists here. So I have an x minus 2. I have a 3x plus 1. Here I have another 3x plus 1, but it already exists here, so I'm not going to write it again. And this would be a 2x minus 5. So here is my LCD. And again, we're not going to touch it unless we need to at the very end. Now let's go back and figure out what everything was missing. At the top of the first fraction was a 2x minus 3. We need to figure out what from here is missing from the LCD. It has the x minus 2 and 3x plus 1. It did not have the 2x minus 5. So this will get multiplied with 2x minus 5. Plus, from the plus sign, we already had the x minus 6 here at the top. We've got to figure out what part of the denominator is missing here that's in the LCD. So we already have a 3x plus 1 and a 2x minus 5. The part that's missing is x minus 2. We'll do the same thing we did with the last problem, where we'll go through and try to FOIL all of this out. Again, the denominator does not get messed with. 2x times 2x gives me 4x squared. 2x times negative 5 is negative 10x. Negative 3 times 2x is negative 6x. Negative 3 times negative 5 is 15. Plus x times x, which is x squared. X times negative 2, which is negative 2x. Negative 6 times x, which is negative 6x. And negative 6 times negative 2, which is positive 12. We'll look to combine like terms. Again, the LCD does not change. 4x squared and x squared become 5x squared. Negative 10x minus 6x minus 2x minus 6x. So negative 10 minus 6 is negative 16. Minus 2 is negative 18. Minus 6 is negative 24x. And 15 and 12 make 27. Again, we would look to see if this doesn't factor. And as we go through and check, it actually wouldn't. So if it doesn't factor, this would be left as your final answer. If it did factor, we would look to factor it and see if anything could cancel out at the end. And if it did, we would simplify it like we do our rational expressions. Let's do one more here. So again, before we go through and find the LCD, the denominators need to be factored. This one here can be factored with difference of squares, minus. And this one here can be factored with a equals 1. We need to find something that multiplies to negative 10 and adds to negative 3. So we would get t minus 5 and t plus 2. So again, for my LCD, we're asking, what do we have here that's unique? We have a t minus 5. We have a t plus 5. We already have a t minus 5 here, so we'll not write it again, but we also have a t plus 2. So that will be the LCD for this fraction. Let's go back and adjust the top. So I already had a t up here, and now I'm looking for what did this first fraction have in the LCD that it doesn't have here. So we see it has the minus 5 and the plus 5. It does not have the t plus 2. So that needs to be here in that fraction. A minus 3 already here at the top. And we'll kind of do that in blue because we already had that value. But we're going to treat it as a negative 3 because of the minus sign. What does this denominator have in the second one that the other one doesn't? It has a minus 5 and a positive 2, but it does not have the positive 5. So this will be t plus 5. We'll look to simplify this. Again, the denominator does not change. T plus 5, t minus 5, and t plus 2. T times t is t squared. T times 2 is 2t. Negative 3 times t is negative 3t. And negative 3 times 5 is negative 15. Combining like terms here, we've got t squared. 2 minus 3 will give me negative t. minus 15. And here we'll have t plus 5, t minus 5, and t plus 2. Again, a quick check here. This is a equals 1. Is there anything that multiplies the negative 15 that gets me a negative 1? There isn't in this case, so we would leave this as our final answer. The big thing here is understanding how to get the LCD and then what to multiply the numerators by when you do it. We always multiply the numerators by whatever is missing from the LCD in each fraction. Let's do two more. So here we need common denominators. Now in this case, these are already factored, and that's as far as it will go, and they're each unique. So I'm going to use both as part of my LCD. So my LCD is going to be y plus 3 and y minus 3. We have the 4 here. It had the y plus 3. It's missing the y minus 3. So I need the y minus 3 here when I do that one. Plus 5y. But again, we're going through what is this fraction missing from the LCD. It has the y minus 3. It's missing the y plus 3. So that will be part of my fraction moving forward. Again, the denominators do not change. 4 times y gives me 4y. 4 times negative 3 is negative 12. 5y times y is 5y squared. And 5y times 3 is 15y. Looking to go through and kind of rearrange this and put this in descending order while combining like terms. I have 5y squared, 4y, and 15y make 19y minus 12. Let's check and see if this can factor. This would be AC method. So I have A and C. I have 5 and negative 12. That makes negative 60. So I have to check and see, is there anything that multiplies the negative 60 that can get me a 19? I've got 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. So when I look here, looks like there's something that could get me 19, and we think it could be 4 and 15. However, I need this to be a negative 60 and make this to be positive 19, and there's no way for that to work. The only way this would ever be negative 60 is the signs have to be different. There's no way for the signs to be different and make a positive 19. So this one would not work. There's nothing else here that will get me to 19, so this will end up being my final answer. Let's do it one more time with letter D. Again, we need to find the LCD. It's already factored because these are binomials, and notice these are not the same. So these both need to be in my fraction. The LCD in this case would have z minus 5 and 5 minus z. Both of these would be included. These are not the same. They are completely different. Here at the top, I've got a 3z minus 18, and I'm looking for what do I multiply this by. This one had the z minus 5, so it needs to be multiplied with the 5 minus z. Here I've got a minus 3, and this fraction had the 5 minus z, so it did not have the z minus 5. So I will multiply this with z minus 5. We're going to go through and FOIL out this and then distribute out this. So we're going to do 3z. So let me rewrite this down here. Kind of give us a little bit more space. So we're going to go through, FOIL this out. 3z times 5 is 15z. 3z times negative c is negative 3z squared. Negative 18 times 5, negative 90. Negative 18 times negative z, positive 18z. Negative 3 times z is negative 3z. And negative 3 times negative 5 is positive 15. I'll try to look to combine everything here. This is the only thing that has the squared, so negative 3z squared. Here I've got 15z and 18z and negative 3z. So all of those can combine. 15 minus 18 is negative, 15 plus 18 is 33z, minus 3z is 30z. And then negative 90 plus 15 would give me negative 75. So I do that, I'm left with z minus 5 and 5 minus z down here. Now one of the things we'll notice here is that there is a GCF here. So we need to try and see if we can factor the top and see if anything can cancel. So I notice that 3 goes into each of these, and that's a leading term of negative. So I'm going to factor out a GCF of negative 3. So I factor out a 3, negative 3. This now becomes z squared. 30 divided by negative 3 is negative 10z. And negative 75 divided by negative 3 is 25. Again, the denominator does not change. But now on the inside, I should be able to do a equals 1 here. I need something that multiplies to 25, but adds the negative 10. So in this case, that would be negative 5 and negative 5. So here the top becomes z minus 5 and z minus 5. And the bottom still remains the same. But now that the top is completely factored, we can look to see, is there anything that can cancel? And we'll notice here that I've got z minus 5 and z minus 5 on the top and the bottom. I won't cancel the second one because I already canceled this out here, but I do notice that z minus 5 and 5 minus z, these are opposites. And when you cancel out opposites, it becomes a negative 1. So the only thing I have left here is negative 3 times negative 1, which just simply gives me 3. So this was a great example of, we went through, we found the LCD, we rearranged the top, and then we looked to factor the top to see if anything could cancel. So you have to go through and check, can you factor the top to be able to get the answer? If you're struggling on MyMathLab, that's a possible reason why. Make sure that you can factor the top. If you can factor the top, then we've got to reduce and simplify the fractions like we showed you in the last video.